Hello and welcome to Physics Doctor. This is Dr. Ghanshyam Rejani and let's start. Class 11, chapter number 3, Motion in a Straight Line. In the similar chapter, it is covered in the JEE and NEET unit number 2, which is called Kinematics. And this is session number 8 of chapter number 3. What are we going to learn today? Graphs. Isn't it new for you? I don't think so. So, to be precise, we are going to learn one is position and time graph, velocity and time graph, acceleration time graph, and also how to read this graph. And we will be solving large number of examples, right? That examples are from NEET, JEE as well as from the books also. And today we are going to solve 44 examples. So be happy with this. Let's start. See what is graph? So it is just a graphical method for what? To study a motion of an object. What are we going to do? Motion of an object can be represented by a position time graph, velocity time graph, and acceleration time graph. Such graphs are powerful tool to present and analyze different aspects of motion of an object. If you see our previous session, we have been studying motion subjected to one dimension. In this graph also we will be targeting one dimensional motion. And there are two methods. One by using mathematical equations. We have equation of motion for velocity. When velocity is constant, equation is delta s divided by delta t. We know that if acceleration is constant, we have equation. What is equation? V is equal to u plus at. Also, we have two more equations. V square is equal to u square plus what? Plus what? Tell me all the equations. Let's see. By using these equations also, we can solve. But there is one more method. There is one more method. There is a graphical method, and we can use this one. Let us understand the detailed explanation. First, let us start with various graphs with the use of a straight line. You know the straight line meaning is that it is giving a short test distance between 2 points. If I take point number A and point number B at here, if I join this with a short test distance, that become line. That we know already. So we are starting with straight line. How it works? So it gives a linear relation between y and x, and that represents a straight line. That represents a straight line. We consider here this is x-axis and that is y-axis, and if you draw a line, that is a straight line, and we know that equation of a straight line. What is? Tell me. Yes, sir. It is y is equal to mx plus c. It is well-known equation, and everyone know it very well. And you must have studied this equation many a time. Of course, I agree with you. Definitely, we know this equation in a detail, but let us understand with some more details. Because in the analysis of graph or preparation of graph, we need a thorough understanding of this equation. So here, in this y is equal to mx plus c, the term m, it represents a slope. It shows slope of line. Here, if you see drawing number 1 and drawing number 2, both are given. And this is a line we are talking about, that equation is equal to y is equal to mx plus c. And this m, it represents slope. Slope, that means this theta angle, and therefore it becomes m tan theta, m tan theta. So that is slope. That is slope. We can also take the distances. Say for example, if we give name, this is a, B, C. And if you wanted to have solution tan theta, so we know that it is a perpendicular side divided by nearer side. That we can get. That we can get. That we know, right? So this is ultimately what it is, a slope. It is. And C, that is another constant. We know that C is a constant. C is a constant, but it is also known as intercept. It is also known as intercept, or to be precise, it is known as y intercept. Not y, not why. It is not y. Here it is y. Intercept. See, when x is equal to 0, when x is equal to 0, that means that term is 0. Y becomes C. Y is equal to C. Y is equal to C, and it shows that graph passes through which line, graph passes through which point, that is C, that is C, it is showing like that. So here this is y intercept where line cuts the y axis. If C is positive, if C is positive, it cuts above this line. This is x and that is y, so above x line. And if C is negative, that means it should cut below xy line. That should cut below xy line. That you have to understand in detail. So slope, we know that it is defined by tan angle of right, tan angle made by the straight line with positive axis in the anti-clockwise direction. The line, if you want to represent this angle, it is with x-axis. It is with x-axis, and it should be in the direction of anti-clockwise, or we can say counterclockwise. So we have to move in this side, and this angle, this is the angle. This is the angle. We cannot take opposite side. You cannot take opposite side. This is wrong. This won't be. Similar here, if you see another line, there is another line, there is another line. So again, we need to take x-axis, and angle should go in the direction of counterclockwise. So anti-clockwise, that becomes theta. So here there is a important conclusion, that is a theta for this line. If you see theta, it is less than 90 degree. When there is a theta is less than 90 degree, so tan theta, we know that 0 to 90 degree, it give always positive value. So that become the slope. When theta is less than 90 degree, slope is greater than 0, or simply we can say m is positive, or simply we can say slope is positive. And when this theta, if you see here in this second case, it is definitely greater than 90 degree. It is definitely greater than 90 degree. So in this case, tan theta become 90 degree. Tan theta become negative value. It become negative value. Therefore, this slope is less than 0, and that become negative. That become negative. So when there is a angle is less than theta, slope become positive, and when that angle is less than theta, slope become negative. It is simple conclusion that we have to know it very well. And here theta is always lies between 0 and 180 degree. It must be always in between 0 to 180 degree, right? So again, if this theta is less than 90 degree, if theta is less than 90 degree, it is slope is positive. If theta is greater than 90 degree, slope is negative. Slope is negative. This is very important part. That means slope, it is represented by m, and m is equal to tan theta. M is equal to tan theta. And another part, C. If C is positive, it cuts above xy line. If C is negative, it cuts below xy line of y axis. We will see more in detail also. Now, so we know that C is equal to y intercept if x is equal to 0, when there is a value of x is equal to 0. So at the time, this line cut this line cut y-axis. This line cuts y-axis. So it shows the point where line cuts y-axis. So in the figure number one, this is we are talking about this figure, right? Slope. We know about slope. When this is less than 90 degree, slope is positive, and when this intercept is above x, that means positive. That means it is also positive, right? So here both are positive. C is also positive as well as M is also positive. Then next figure, figure number two, it is here. What about theta? Theta is greater than 90 degree. It is clearly visible. That means slope is negative. That means slope is negative. M is negative value. M is negative value. C, it cuts above, right? Y cuts above this x axis. That means it's a positive. C is positive. In the figure number three, this is the figure number three. Figure number three. See, we have to draw this line, and that angle should be with x. Angle should be with x, and we have to go in the direction of counterclockwise. So of course, this angle is less than 90 degree. This angle is less than 90 degree. Theta is less than 90 degree. So slope is positive. Slope is positive. And C intercept. This is y intercept. This is y intercept. It is below x line, so it become negative. C become negative. C become negative. So for the C, there are these options. There are these options possible. Then if C is equal to 0, 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 that means what? Original equation is y is equal to mx plus c. That means y is equal to mx. Y is equal to mx. Y is equal to mx. Right? So this has to pass through, the line has to pass through this origin, because it is C is equal to 0. C is equal to 0. So this line has to pass, it may be in this direction, whatever, positive. If it is positive, so it should like that. This is the theta, and it should passes through the origin if C is equal to 0. If C is equal to 0, we know it very well. See, these small concepts are very much important, because physics, when you're talking about JEE NEET, it deals on concepts, and you have to understand all the concepts. Next is y is equal to c. Equation is what? Y is equal to mx plus c. Y is equal to mx plus c. That means this term it is omitted. Y is equal to c. That means x is equal to 0. For all values, y is constant. For all values, y is having just a constant one value. Whatever value we take for x. So this is here x value. X is 0. Y is c. X is 1. Y is c. X is minus 1. Y is c. That means it gives a straight line. It gives a straight line, and that line is also parallel to x axis. That line is parallel to x axis. So when x 0, or simply you can say y is become c, at that time line is always parallel to x axis. And similar, when x is c, equation, what is the equation? Y is equal to mx plus c. If this term it is not there, it is not there, right? And here x is equal to c, x becomes c. M is also constant, so you can take an opposite side and direction can be flipped. So at that time, for any value of y, if y is equal to 0, x is c. Y is equal to 1, x is c. Y is equal to minus 1, x is c. It gives straight line, vertical line, and it is parallel to y axis. So this you have to understand when we are talking about different graphs. This is different properties of a straight line. So one example, let's take an example. Draw the graph for the equation 2y plus 4x plus 2 is equal to 0. So we know that equation of line is equal to y is equal to mx plus c. We have to convert this equation 2y plus 4y plus 2 is equal to 0 in this term. Can we convert this equation? Of course, we can. It is very simple. So y, just divide this by 2, this by 2, right? So it becomes like y is equal to something x, something c. So simplification is given here. Y is equal to 2x minus 1. It is very simple. We know it very well. From that, can we identify values? M is minus 2. That means M is negative. M is negative. One thing. Second thing is that C is minus 1. That means C, the Y point will cut at minus 1. That means Y intercept, the line cuts one position. It is 0, comma minus 1. 0, comma minus 1. It cuts at this position. M is negative value. That means theta should be greater than 0. Theta should be not 0. Theta should be greater than 90 degree. So this should be greater than 90 degrees. So line it is like that. And tan theta is equal to minus 2. Tan theta is equal to minus 2. That we know it. That we know it very well. So we already seen that C is equal to minus 1. So that line should cut at 0, comma minus 1. 0, comma minus 1. Then we can put values. We can put values here at y is equal to 0. At y is equal to 0, we can take y is equal to 0, and we may find value of x. Value of x. So x is equal to minus 0.5. We already have 1 point. Here y is equal to 0. So that next point becomes 0.5 minus 0.5, comma 0. So another point we can find. It is very simple to get it. So line passes through another point minus 0.5, comma 0. First represent x value. Second represent value of y. So it is very simple. Let's have one more. Through the graph or the equation 2y plus 3x plus 2. What is the equation of line? Y is equal to mx plus c. We need to convert this into that equation. That means you just divide this equation by 2. By 2. What become? This become 3 by 2x plus 1. 3 by 2x plus 1. What is 3 by 2? M C1. C1. From that C, directly we can identify it is going to cut y axis at position 1, 0, comma 1, 0, comma 1. And M is positive. That means angle theta should be less than 90 degree. Theta should be less than 90 degree. So tan theta is equal to 3 by 2. Tan theta is equal to 3 by 2. We can put y intercept. We already have. So line passes through 0, comma 1. That we all know very well. What next? We can find next point, or we can take slope. We can take slope. So this side should have 3, and nearer side should have 2. Is it correct? Is it correct? Is it correct? Think and tell me. Think and tell me. So how another point we can find, x is equal to c minus c by m, where we take y is equal to 0, y is equal to 0. Put this value, y is equal to 0. So we can find x is equal to minus 2 by 3. X is equal to minus 2 by 3. So here that point is minus 2 by 3, comma 0, and you can draw a line. So representation of line is very simple. Let's initiate position time graph by taking very simple example. So example is given like that. Consider the simple case in which an object is stationary. See, in the case of position time graph, we can take one that is vertical line, and second that can have horizontal line, and at one side we can show time. This is axis representing time, and another side can represent its position. We can say x as a position. So what is given? Consider the simple case in which object is stationary. So say for example, time is equal to 0. Time is equal to 0. X is stationary. X is having stationary at some distance. Say for example, x is staying somewhere here. At some distance, it is at stationary. X is equal to 1, for example. At time is equal to 1 second. 1 second. What is meaning? It is stationary. It should be stationary. So it should be like that. This point should be here. At 2 second, it is again stationary. So it should be here. At 10 second also, it is stationary. So if we draw its line, what become? We will be having this kind of a straight line graph, right? A straight line graph. When we talk about a simply object which is a stationary, that means it is not having any movement, any motion. Such graph is always like that, a constant. Very simple, isn't it? Second case, if an object moving along the straight lines covers equal distance in equal interval of time, in equal interval of time, it is said to be uniform motion along the straight line. We know that if distance traveled by an object which is equal, so let's do a graph. One side is showing t, another side is showing distance or position of x. Fine. So it start maybe at maybe zero, at time zero. Say for example, if it is located here at 1 second, it is traveling 1 unit. So we can take combine, and that is somewhere here position. Fine. At 2 second, it travels 2 unit. If you combine this two, somewhere here position, and maybe it may be 5 second. At 5 second, it travels five. It travels five, something like that, and it is here. If you draw, if you just plot, if you plot this lines, or if you join this line, so it is going to be a straight line. It is going to be a straight line, but not horizontal, and it is having equal distance on the both the side. It is having equal distance on the both the side. So here we already gone. This is case number A, where it gives a straight line, horizontal line with T, because here X is not moving at all. X is stationary at some particular place. You may imagine like that you start from your home, and maybe 9 at morning 9 if you are at your college, or maybe at your school, right? And your vehicle is outside, right? Your vehicle is outside, your vehicle so from 9 to maybe 5 if your school time. That means you are located at the same place. Your vehicle is also located at the same place. So for that, if I do displacement diagram of your position, it is going to be a straight line which is parallel to T. In the second case, say for example, you are driving your vehicle at 1 meter per second. Means if 1 second is passes, you travel 1 meter. 2 second passes, you travel 2 second. 3 second passes, like that. So it gives us a inclined line, but it is again a straight line. It is inclined line, but it is a straight line, and this gives us uniform motion. This gives us uniform motion along this straight line. Very simple. So this is just a simple position time graph representation. How it works. So first is for stationary object which is not moving, and second is some object which is moving with uniform motion. With uniform motion. Let's have one more example, which is a realistic example. Example number 3 is given, like consider the motion of a car. Say for example, you start your car. So that start from the rest. So we know that when we start a car, it starts from zero. It starts from its zero movement, zero motion, and then there is an increase of speed of a car. Increase of speed of a car. So here it is given when time t is equal to zero. It starts from the origin. So starts from the origin and pick up speed till 10 seconds. So what we do? We initially accelerate our car, and then and initially there is some increase in speed. Increase in speed. Maybe say for example here it is around 70 or 80 kilometer per hour. Let us just assume. Then what we do? We run a vehicle at some constant speed. So there is a straight line. That straight line shows constant speed. If there is an increase, so it shows increase of velocity, or simply we can say increase of acceleration. There is a positive acceleration for that. So thereafter moves with uniform speed. So this region it gives uniform speed. Velocity is constant here. Velocity increases. Then the brakes are applied and the car stops. So brake is applied somewhere and there car stops. Whatever position it is there, it maintain at that position. At maintain. You can take example. Say for example, you start from your home. You may after 2 3 seconds you increase your velocity or speed. So at 8 it may be 8 seconds or somewhere here nearby, or it is mentioned here 10 seconds. So let's take 10 seconds. At 10 seconds you might have reached around 70 kilometer per hour. What you just go on with some constant speed up to some point. Then suddenly if there is some animals, right, or some person, right, they come in between vehicles. So what we do, we suddenly apply brake and there is a speed reduction. There is a speed reduction, right? So here this is the graph for the displacement or maybe a distance travel. So you might have traveled 300 meter and this position can be there. So this is very simple graph to be plot. You may try after this tutorial also. Let's move. Another is average velocity and average speed. What is the difference between average velocity and average speed? We know that. We know it that very well. When an object is in motion, its position changes with time. But how fast is the position changing with time and in what direction? So that define average velocity. When we talk about direction, that defines velocity. So we know that average velocity is equal to v delta x by delta t, x2 minus x1 divided by t2 minus t1. That we know very well. Say for example, in the graph we can see here there is some object start with 0 and that keep on accelerating. Therefore, it is having curvature. That is having curvature and it is accelerating. Then object means traveling along x direction and with respect to t. How this is accelerating, we can see here. If you just see this 5 meter distance travel in a 4 second. But if you see from 4 to 5, that means it is taking 1 second. 1 second it is traveling another 5 meter. Right. So first 5 meter it is taking 4 seconds, but for the next 5 meter it is taking only 1 second. So that's we know that from that velocity is increasing. When we talk about average velocity, so from P1 to P2, we take direction, and from that value, we just find out value of x2, that is 1727.4 minus x1, that become minus 10. And what about time? What about time? It is taking 5 to 7. It is taking 2 seconds. Taking 2 seconds. So it is average velocity. Average velocity is 8.7 meter per second. 8.7 meter per second. But when we talk about speed, we cannot take x2 minus x1 as a straight line. We have to consider length of this curvature. We have to consider length of this curvature. So that gives us speed. That gives us a speed. So remember that part. When there is a talking about velocity, of course, it is the shortest distance you need to take. You need to take shortest distance. But when there is a word about speed, you have to take this curvature. You have to consider this curvature. Otherwise, your answer is definitely going to be wrong for that time. So we know that average speed versus average velocity. We know it very well. Average speed is equal to distance divided by take total time. And when we talk about velocity, so it is displacement divided by time. We have our full session on speed and velocity, distance and displacement. I think you should study from that session so you will have better understanding. Now let us understand few more graphs. The average velocity can be positive or negative. See, when we talk about velocity, it deals with direction. It deals with direction. So this velocity can have a positive value or it can have a negative value. It can have a negative value, it can have a positive value. But can you answer me? Can you answer me that an average speed be negative? Comment me your answer for that. Average speed, is there possibility to have a negative value? Comment me this answer. See, in the examination, you will be treated with this kind of question. You understand that there is some velocity part in this, but there is something mentioned like that speed it is mentioned in the data, but if you calculate for the velocity, your answer is going to be wrong, and you have to understand this. So we understand that when there is the increase of x, if increase of x, that means x2 is greater than x1, velocity increase, velocity is positive, velocity is positive. If here this is x1, this is x2, if x1 is greater than x2, that means velocity is negative. And here last case, if this is the last case, let's see here, there is no change in terms of displacement or distance. That means here there is no velocity or part at rest, or velocity is equal to zero. There is no velocity. It is not moving. Component is not moving. Object is not moving. Let's take an example. Example number 4. A car is moving along a straight line, says OP. So it is given here. This is car is moving from O to P. This distance it is traveling in the figure. So now it moves from OP. It moves from O to P in 18 seconds and returns from P to Q, and it returns from P to Q in 6 seconds. In 6 seconds. What are the average velocity and average speed of a car? First position is going A from O to P, and B is given from O to P and back to Q, from back to Q. See, we have a full session on displacement and distance, velocity and velocity and speed. I think if you do not know what is meaning of velocity and what is meaning of speed, I think you should take that session in advance. So let's start with this our understanding part. So how it works? So velocity, we know that velocity is a vector quantity directional property, so is equal to delta x by x, delta t. So that is become x2 minus x1, t2 minus t1. That is here delta x. It is displacement. When we talk about average speed, it is total distance travel. Total distance travel, right? Direction doesn't matter. Direction doesn't matter. Divided by the same time, similar time. So when we talk about first case, it is asked the average velocity and average speed of car from O. Object starts from O for the first case and it moves to P. For it travels 360. So we know that V bar is equal to delta x, 360 travels, and it is taking 18-second time for the first interval. So 360 by 18, that become 20 meter per second. And what about average speed? Total distance is 360 and total time is 18 seconds. That is, the both the answers are correct. So see, average velocity and average speed can be equal. Average velocity and average speed can be equal. In the second case, it is mentioned that the object moves from O to P. That means it is traveling 360 in 18 seconds, and it is returning it is returning to 240 means q. That means this distance has to be reduced when we talk about velocity. So in case of average velocity, distance is travel, it is the shortest distance we have to take. So it is 240. So it is 240 divided by total time 18.6, that is 10 meter per second. But when we talk about average speed, so we have to take total distance. So here 360 plus this 120 divided by total time. Time is similar. 18 plus 6 is 20 meter per second. Is 20 meter per second. So velocity, it is 10 meter per second because here we need to consider direction. But when we talk about speed, so it takes total distance. It is taking total distance, right? So here it is 20 meter per second. 20 meter per second. So what say this shows that speed in general greater than magnitude of velocity. Speed, right? We can write greater or equal to. On based on that, you may find several questions also. You may find various questions based on this. So average velocity, you can take less or equal to average speed. You can write in the opposite part also. Now we understand what is velocity. Now let us understand acceleration. So the velocity of an object in general change during course of motion. It is just showing a course of, okay, this change of motion with time. We know that very well. So see, should it be described as a rate of change of velocity? So see, before the acceleration was defined at that time, people were confused. What should be acceleration? What should be relation for that? Should I be velocity with distance? Means velocity divided by distance, it should be acceleration, or velocity divided by time, it should be acceleration. There was a confusion among scientists, among researchers, and this was also a problem. It was faced by Galileo. Yes, sir, Galileo's time. The problem was there. How to define this acceleration? There was no logic for that. So firstly, it was defined as it is a rate of change of velocity with displacement. Initially, definition was given. Acceleration word was not utilized at the time, but see there was some change in the velocity. It was seen, and how to define for the further activities. So it was initially defined like that: change of velocity with distance. See, we don't have any term as of now. Even today also, we don't have velocity divided by distance. Do we have velocity by distance is equal to any term? If you have, please comment me. We don't have any. So what happened? See, then Sir Galileo. Yes, sir, we have to take sir. Sir Galileo studied motion of a free falling object. So object, when it is free fall, he identified that change of velocity with respect to time, it is constant. When object is having free fall, so that Galileo identified that velocity, change of velocity with respect to time, it is a constant, right? And velocity with distance, say for example an apple is falling from the tree. So it is having some velocity v1 here, it is having velocity v2 here, and traveling distance, say for example h1, right? And it is taking some time t1. So here v1 by t1 we can consider, and we can consider v1 by h1. Again, it is moving in the direction, it is having v3, taking some time, say for example t2, it is traveling distance h2. So if we take, or you can say v1 minus v2, right? v2 minus v1, right? And here you can take v3 minus v2 divided by t2 taken, and v3 minus v2 divided by time taken, not time but h2. So in the case here, Galileo identified that this ratio of v to t remain constant. Ratio of velocity to time remain constant. That in this case, acceleration was defined and average. Not it is not velocity, but it is acceleration. Average acceleration is equal to delta v by v is become v2 minus v1 divided by t2 minus t1, and we not to worry about now about this term. Do you know this answer? What is change of speed with time? What is change of speed with time? See, average acceleration is not a change of speed. It is a change of velocity. It is a change of velocity. See, but as we have only acceleration. Do we have any other term like we have for the speed and velocity? But do we have any other term in the case of acceleration? Actually, we don't have any term for this. And alternately, acceleration is used for the speed change of velocities as well as speed also. But you can be the next Galileo or next Newton by answering this question. You may give name for this average, or you can say change of speed with time. You please comment me your answer in the comment section. So now acceleration that was defined like that in the history. How to plot acceleration graph? See, we already studied various equations for the acceleration in terms of constant acceleration and motion graph. Here the acceleration is non-uniform and linear over the period of 0 to 10 seconds. Say for example, the data is given like that. Acceleration, it is non-uniform, and it is linear. It is linear from 0 to 10 seconds. So it is just either it is increasing or decreasing. Acceleration is positive, so it is increasing with a straight line up to 10 second, up to 10 second. That means velocity is also increasing. Simply, logic is very simple. It is object, it is increase with velocity. Fine. So from 0 to 10 second, there is some acceleration. There is increase of acceleration we can identify here. Then acceleration becomes 0. Acceleration becomes 0. So it is on the 0. Acceleration from 0 to 18 seconds. So here acceleration is 0. And here acceleration is having some value. We don't know. We will learn this part. So acceleration is 0 from 10 to 18. Then there is a from 18 second to 18 second to 20 second. There is a constant deceleration, we can say, or retardation. If there is a minus signature, minus sign, so there is a minus 12, and it is a constant. It is a constant retardation from 18 to 20. It is minus 12. See, this case we can draw, or we can plot acceleration versus time graph like that. We will take more example. Don't worry at all. This is just I'm showing sample for the acceleration. So here there are two conditions we can see. When acceleration is equal to 0, line it passes through x or x axis or timeline. Here it is 0. When there is a linear increase, so it is showing a slope, positive slope. It can be a negative slope also. And when there is a negative, so here it shows directly a straight line. When there is a constant part, negative position and constant, so it is showing a straight line. Very easy to understand, I think.